In this video I am going to explain Pythagoras theorem, and it states that in a right angle triangle the square of the hypotenuse is equal to sum of the squares on the other two sides of the triangle. Okay? It states that in a right angle triangle the square on hypotenuse is equal to sum of the squares on the other two sides of the triangle. So this, okay, I am going to prove it. Just watch. See, this is the statement of Pythagoras theorem. In a right triangle, the square of the hypotenuse is equal to sum of the squares on the other two sides. Okay, so let me draw a right angle triangle. This is a right angle triangle. It's like this. Okay, this is ABC, A, this is B, and this is C. Okay, ABC is a right angle triangle. A right angle at B, right angle at B. Okay, now so right here, now solution starts from here. So ABC is a triangle. ABC is a right angle at B, the right angle at B. Okay. Now to prove AC square is equal to AB square plus BC square. This is what to prove. You know, AC is a hypotenuse because AC is opposite to the right angle B. Therefore, AC is the hypotenuse, and the other two sides are AB and BC. So the square of the hypotenuse is equal to sum of the squares on the other two sides of the triangle. This you have to prove. Now for this you have to do the construction. So drawn, this is D, drawn BD, perpendicular on AC. Okay, BD is drawn perpendicular on AC, right? BD is drawn perpendicular on AC. Now, proof. Now the proof. So we'll compare triangle ABD with ABD triangle with triangle ABD triangle. It's okay to triangle this ABC triangle, the big one, right? Yeah. So and this triangle, angle BDC triangle with this ABC triangle, we will compare like this. Okay, these two triangles, this is small one, and this, okay, will be compared to the bigger triangle ABC. Is correct? So in triangle ADB, in triangle ADB, I am taking ADB, and okay, and triangle ABC. So okay, ADB and ABC triangle. Is correct? So they are equal. Now angle A is equal to angle A. It is common. and angle, angle ADB is equal to angle ABC. Okay, ABC, each 90 degrees. This is okay. Therefore triangle, triangle ADB is similar to triangle ABC. So that is angle similarity. Angle similarity. It is similarity. Is okay. Triangle ABD is similar to triangle ABC. Okay. Now I will rub it. Okay. I am going to rub this one. So wait for. Now I am proceeding from here. We have proved that triangle ADB is similar to triangle ABC. Now take the ratio. So AB okay, AB by AC. AB by AC is okay. AB by AC is equal to DB. DB by AB. Okay. Do you know why I have taken in this way? Because the aim is to prove that AB square is equal to AD square plus BD square. This you have to prove. Okay. So this implies that AB square is equal to AC into DB. AC into DB. So this is A. This is AB we have taken. This is AD. This should be AD and AD. This is AD. Okay. This is AD. So AB square is equal to AD into AC. This is AD like this. AC into AD is correct. This is equation 1. This is 1. It is. Now second equation. Now take this triangle small one, compare this small triangle with the big triangle. So in triangle CDB and triangle CDB and triangle CBA. It's okay. Now to make CV square. Okay. So okay, they are similar. Okay. Angle, why is similar? Because angle C is equal to angle C. This is common. It is. So and angle, CDB is equal to angle CBA. Why? Because each 90 degree. That's why they are equal. Therefore, the same way, triangle CDB is similar to triangle CBA. So okay, this is similar. Now take the ratio. So it is now take the here BC by this is A. BC by AC. BC by AC is equal to, we have to make it here down. This is BC. And BC, you take here whatever DC it is. This is DC. It's correct. Now this is equal to what? Now cross multiply this one. So this is BC square is equal to DC into AC. This dot means into sign. It's correct. Yeah. Now let it be equation number 2. This is 2. This is 2. So add up 1 and 2. Add up 1 and 2. This is 1. This is 2. Add up. So adding 1 and 2. Adding 1 and 2. It's okay. What we get? We get now AB square plus BC square. This AB square and BC square is equal to AC into AD plus DC into AC. It's okay. It's right. This is. So now take the common here. So it is AC. What is left here? Left is AD plus DC. And AD plus DC is AC. It's correct. So AC into this is AC. Do you know why this AC? Because since AD plus DC is equal to AC, that's why. It's clear? And this is equal to this AC square. It's correct? And this we have to prove. So we proved that. Now therefore hence it is proved. Therefore hence you can see therefore AC square is equal to now AB square plus BC square is proved. This is very important one. This is an important theorem. I think it is also easy one. It's correct. So this is one question based on this Pythagoras theorem. So prove that the sum of the squares of the two sides of a rhombus is equal to the sum of the squares of its diagonals. It's okay. Let me draw a diagonal as rhombus. This is a rhombus. You know what is rhombus? A rhombus is a parallelogram whose all sides are equal. Okay, it is parallelogram whose all sides are equal, or you can say a rhombus. This is A, this is B, C, and it is D. It is it's okay like this. Which all the four sides are equal. Rhombus. This is rhombus, and the rhombus. Okay, a rhombus. A B. Let it the naming should be done in this way. This is A, this is B, this is C, this is D. It's okay, this is C. And the rhombus, the diagonals of a rhombus intersect each other at right angle. So to prove that, now so the sum of the squares on any two sides of a triangle is equal to sum of the squares on its diagonal. It's okay. And in a rhombus the diagonals also bisect each other. Okay, and they bisect each other at a right angle, and so just you can say in triangle, in right angle AOB, in this triangle, in the right angle AOB. Okay, in right triangle, in the solution starts from here, in right triangle AOB. It's okay. In right angle AOB, AB square is equal to what? AO square plus BO square. It's correct. AB square is equal to AO. This is right angle triangle, so AB square is equal to AO square plus BO square. It's correct. Or you can say that now AB square, or you can say that AB square, that implies AB square AO square. You know, A square, AO is half of AC, isn't it here? AO, this AO is half of AC. So you can write like this. AC, it is like this, it's correct. And you know, this BO, this is BO is half of BD, isn't it here? Half of BD, half of this is BD, make it square. Okay, this is because this is on square, therefore it is square. So how much will get here now? Half AC square plus 1, this is 1 by 4. 1 by 4 plus 1 by 4. This is BD square. It's correct. BD square it is here. Okay. Now transpose this to this side. So what we will get here now? Here, take the LCM. So LCM will be 4 like this. So it is AC square plus BD square, and this is AB square. So this is 4. Correct. Now transpose this to this side. So you can 4AB square is equal to AC square plus BD square. AC square plus BD square. You know, all the sides of the rhombus are equal, therefore you can write like AB can be like this. Say AB square plus BC square plus CD square plus DC square. Isn't it? You can write like this. Can you? Yes, it can be written like this. It is. So this is equal to what you get is this is equal to AC square plus BD square. So this is the sum of the squares. Okay, so the squares on the sides of the rhombus is equal to sum of the squares on the diagonals of a rhombus. So this is proved. This is proved. It's okay. This is proved now. You know why? Okay, why? How has this come? AB square, BC square, CD square, DC square? Because this is 4AC, 4AC, and AC is equal to BC is equal to CD is equal to DC. So all the sides are equal. Therefore, okay, this 4 becomes AB square, BC square, CD square. So this is the proved last statement. This is proved. This is proved. It's correct. Sure.